All right, y'all, we're looking at topic 9, the second section of it. Today we're talking about a particular set of right triangles. All right, this is the very beginning of the top of this idea. Okay, we start off with just one right triangle right here by itself. Okay, triangle ABC. We know it's a right triangle because it's got this little square up here in the corner that tells us that this right here, that is a right angle. Okay, so what I want to do with this diagram, which is also on your paper, what I want to do with this is I want to drop an altitude from corner C. I want to drop it straight down so that it makes a right angle with AB right there. Okay, when we drop it straight down, we're dropping an altitude. That's what that's called. And when we do that, something in particular about this altitude is that it makes a right angle with the hypotenuse of our triangle. Okay, so both of those right there are right angles when it comes down and makes that. And what we've done by dropping down that altitude is we have created three different triangles. Okay, obviously we split it into one triangle on the right that's really small, one on the left, but we also can't forget the original triangle that we started with, right? We've got these two, ADC, we've got BDC, but we've also still got our original big triangle. Okay, so this is how we're going to talk about these triangles. This is the terms that we're going to use when we talk about these triangles in this section. We're going to talk about the big triangle, the medium one that's on the left of this picture, and the small one that's right here. Here's what we need to know about these triangles: the big one, the medium one, and the small one. This theorem right here, the right triangle similarity theorem, says that the altitude to the hypotenuse of a right triangle, what it does is it splits the triangle into two triangles that are similar to the original one. Okay, so what I'm saying here is that our big triangle, our small triangle, and our medium one right here, they are all similar to each other. Okay, that's what I'm saying, is that all three of those different triangles are similar to each other, and that was created by the altitude, and they're all similar to the original. They're all similar to each other. That's going to be important here in a minute when we get to the practice problems. The next thing I want to talk about is what's called the geometric mean. Okay, the geometric mean of of a pair of numbers has to do with comparing the lengths of some of these line segments. Okay, and here's what the theorem says: it says that when you look at the medium triangle, okay, and we look at AD and CD, that's the two legs of the medium triangle, right? AD and CD is the two legs. Well, that's the same thing as looking at the small triangle with with CD and BD. Okay, the two legs of the small triangle. Now we know that these triangles are similar. Okay, we know that the medium and the small triangle are similar to each other. So if we look at the ratio of the long leg on the medium triangle, compare it to the long leg on the small triangle, that's the same ratio as looking at the short leg of the medium triangle and the short leg of the small triangle. Okay, we know that since these triangles are similar, that this has to be true. This ratio, this proportion is constant across both of the triangles. Now, what this does for us is we can find the actual length of this thing by using this theorem and what we call the geometric mean. This theorem says that the length of the altitude, that line that we drop down right here, CD, the length of the altitude is what's called the geometric mean. And finding the geometric mean of a pair of numbers is really very simple. Okay, you just take those two numbers and you multiply them and you take the square root. Okay, and really conceptually, this is kind of easy to follow because what we're doing, seriously, what we're doing is cross multiplying and solving for CD. Okay, we multiply AD times BD, and that would be equal to CD times CD, which is CD squared, yes? And because of that, here, let me see if I can get this. AD times BD. And because of that right there, if we wanted to get CD by itself, we would just take the square root. And that's where this equation right here came from. Okay, so we're going to do a couple of sets of problems. Actually, you know what? First, I want to talk about this. Okay, the altitude of the hypotenuse. Okay, these two things right here were our theorems. Okay, the altitude of the hypotenuse divides the hypotenuse into two chunks. Okay, AD and BD are the two pieces of our original big triangle hypotenuse. Okay, since CD is that altitude, the geometric mean of AD and DB, if we can find that, then that means we can find the length of this altitude right here. Okay, so we're going to look at our ratios. We're going to look at a couple of problems and a couple of different ways that we can solve these problems. The first one, going to the next page of your packet, the first problem is pretty simple. Okay, find the geometric mean of 8 and 12. When we talk about the geometric mean, the way we were looking at it on here is, how could you find the length of this segment right here if your two pieces of the hypotenuse are 8 and 12? And that's what we would have right here. We would have 8 and 12, and this is the part that we were looking for. Okay? Set it up. Take a look at what your triangles would look like when you're with your big triangle, medium, and small triangles. In that original diagram, when you look at it, that this piece, one of this leg of the triangle, would be 12. The short leg of the small triangle would be 8. Okay, 12 and 8. And this piece right here, CD, is the same for both of them. So it's X and X. So what that means is we can set up this ratio. If we're comparing this ratio, well, that's the same thing as saying 12 and X. That ratio of 12 to X is the same as the ratio of X to 8. Now, we could set it up like this and solve this big old ugly equation, but really all we need to know is the process itself, okay? And the process for finding the geometric mean, super simple. Take your two numbers, multiply them together, and take the square root. So we're just looking for the square root of 12 times 8. Now, this notation that's about to pop up is something that we probably won't use very much, but you'll probably see it again eventually, probably in Algebra 2 and Pre-Cal a bit. But what you're going to do right now is all we need to know is that x equals the square root of 96. You can punch that into a calculator, and it'll give you a decimal answer that's roughly 9.79. Okay, on Canvas, this is how your answer choices are going to be selected. This right here, 9.79, in an approximate decimal format. But if you ever see it, this would be what's called the radical form answer. And if you see any answer choices that look like this, you can type them into your calculator and see if it comes out to the same answer as what you punched in, this right here. All right. So that's what we're looking for, the geometric mean. So you can look at it in terms of the process itself being very simple, or you can think about how it relates to these triangles, these similar triangles. Either way, we end up with the same answer, about 9.79. Our next problem, we're actually going to need to look at these similar triangles. All right. So we know from the theorem at the beginning that these three triangles, the big one, the whole thing right there, this triangle that it's split on the left, and the triangle that's split on the right, they're all similar to each other. And what we do with that information is this. Okay, it's asking us to find x. Well, when we look at the similarities on these triangles, we've got information about the big triangle, we've got information about the small triangle. The big triangle, we can see that this leg, the shorter leg of our big triangle, is 8. We can also see the hypotenuse. Okay, the hypotenuse here is split into two pieces, x and 4. But we also know that if we add those two pieces together, just like when we did back at the very beginning of school with segment addition, if we add x plus 4 or 4 plus x, that would be the length of this whole entire thing. That's where this comes from right here. Now let's compare that to what we know about the small triangle. Okay, so we can just cover up cover up and ignore this side of the triangle. We're only looking at this little small one right here. Okay, the short leg is 4. The hypotenuse of the small triangle is 8. Okay, and we know for a fact that this triangle and this triangle are similar to each other. So we can do just like we did in the previous lesson and set up some ratios, set up some proportions that compare the leg length of this triangle to the leg length of this one over here. Okay, that's where this comes from. We've got comparing 4 and 8. That's the leg of the small triangle compared to the leg of the big triangle. And that is going to be the exact same proportion when we compare the hypotenuse. The 8 of the small triangle compared to this 4 plus x of the big triangle. Now, if we are trying to solve this equation right here, we got to do like we were looking at over here and cross multiply. Okay, we got to cross multiply just like we did right here. Multiply that one and that one, that one and that one. Look at what happens. Okay, we multiply 8 times 8. That's pretty simple. We get 64 on one side of the equal sign. When we do 4 times 4 plus x, make sure you are multiplying that 4 times everything on the other side. Okay, that's a very important part of it that a lot of people tend to miss, is that we got to distribute that 4 to both of the things from the bottom of this fraction. Okay, so we got 64 on one side. We got 4 times 4 plus x. We distribute that. And this becomes a very simple equation to solve. Okay, we've got x, we've got let's throw it back and put it in those terms that we did with x throwing a party. All right, our variable x is throwing a house party, and he invites some friends and some family members. Now, obviously, x is going to be closest with his family members, so that's what this 4 is. Okay, his friends are 16. His family members are this 4 right here. Okay, so think about this. At the end of a party, when there are family members involved, all of your friends are going to leave first, because in your family, all the old people got to sit around and talk for days and days and days, right? So what's going to happen is your friends leave first. So we got to ask ourselves, how do we get rid of the 16 that's in this equation? And we have a positive 16 right here. So what we're going to do is we're going to subtract it on both sides. All right, so we minus 16 on both sides. We end up with 4x equals 48. So the next question, at the end of the party, X wants to go to bed. He has to kick the family members out, even though they've been staying around and talking as the old people do for so long. What he does is he divides out this 4. Okay, what's happening is 4 is being multiplied times x, so we have to undo that by dividing it. Divide by 4 on both sides, and we find that x equals 12. And that ends up being our final answer right there. And it makes sense when you look at this equation. If you plug it back in to check your work, if you plugged it back in right there, you would end up with this. You would end up with 4 over 8, which equals 1/2, and you would end up with 8 over 16, which also equals 1/2. And that makes sense. That tracks, because we know that this proportion, when we compare the small triangle to the big triangle, it has to be the same for both the legs and the hypotenuse, because they're similar triangles. That's how it works. We've got a constant ratio. We've got a constant scale factor between all of the parts, all of the side lengths of the small triangle and the big triangle. All right, that's all we've got for the notes today. As you're working through the Canvas problems, please let me know when you have trouble or if you're struggling on them, and we can try and work something out. All right, just let me know and I will do my very best to answer the questions. Okay, that's all we have for this section. Y'all have a nice day.